Let's review our exponent rules. First, let's let a be any real number be our base. Okay, so a is our base. All right. And let's let n be a positive integer. So we'll establish that first. Good. All right, then what does it mean to take a, our base, and raise it to the nth power? Well, that means I'm going to take my base and I'm going to multiply it to itself n times. So n products of a. Straightforward enough. So, for example, if I have 2 to the 4th power, that's the same thing as 2 times 2 times 2 times 2. So I've multiplied 2 to itself 4 times. And that gives us an answer of 16. Great. Now, with just that rule, let's establish our laws of exponents. Okay? Now the first one is, what happens when we take different bases and we raise them to a power n? Well, let's see if we can construct it. We know that that means our base, which is the product of two bases, AB, times AB, times AB, and we do that n times, just as above. Okay, and then if we rewrite our bases so that all the a's are together and all the n's are together, we realize we have a multiplied to itself n times, and then we have b multiplied to itself also n times. We've just separated the two. And that becomes a to the n, b to the n. So what we realize is that if we have a product raised to an exponent, as we have here, then that exponent distributes to both factors, so to both bases. It becomes a to the n, b to the n down here. All right. Similarly, if we have a quotient, a over b, and we raise that to the nth power, the same thing happens. We get a over b times a over b times a over b n times, which the top becomes a to the nth and the bottom becomes b to the nth. So with a quotient, our exponent distributes to both top and the bottom. Now, a common mistake, so I'm going to actually write that in red so maybe we won't forget. A common mistake that many algebra and calculus students make is that they try to distribute an exponent over a sum. So this is the mistake that's made. A plus b to the nth and letting it equal a to the nth plus b to the nth. That is absolutely not true. Exponents do not distribute over sums or differences. They do distribute over products and quotients. Excellent. All right, let's look at some of our other rules. Now, before we do that, let's come over here and let's establish a couple more definitions. Let's go back to white because we're going back to our original. And that is that a raised to the 0 power, we're going to define that to be equal to 1. And another convention we're going to use is a raised to the negative integer is going to be equal to 1 over a to the positive n. Alright, so if we have a negative exponent, we can move it to the bottom and make it positive. Likewise, if we have a negative exponent in the bottom, we can move it to the top and it becomes positive. So that's important as well. Alright, so back to some of our laws here. if we have, so we realize that we can distribute a power over multiplication and quotient, what happens if we have a base raised to a power that we then raise to another power? Well, what that's equal to is a to the m times a to the m times a to the m, you guessed it, n times. Perfect. Which really means I have a raised to the m times n. Correct? You see it? All right. Another rule is if I multiply like bases that are raised to different exponents. So a to the n times a to the m, well, that's actually equal to a to the m plus m. We can see that with an example. If we have 2 cubed times 2 to the 4th, then we have 3 factors of 2 times 4 factors of 2, which gives me a total of 7 factors of 2, or 3 plus 4. So that's an important one. This one is an important one. They're all important. And this one down here should make us also think, if we have a to the m divided by a to the m, so our bases again are alike, then it's the same kind of thing as the one above. It's going to be the difference of our exponents. Perfect. Now let's pause and then come back and work some examples.